Hello, in this video we will talk about t-distributed stochastic neighbor embedding with Python. T-distributed stochastic neighbor embedding, or t-SNE, is a type of data transformation technique, which is usually used to transform the data from higher dimensions to a lower dimension. And usually the lower dimension is 2, so it is possible to show higher dimensional data on a scatter plot on computer. And compared with the previous technique such as principal component analysis and linear discriminant analysis, which are linear transformation of the data based on principal components. And t-SNE is a non-linear type of data transformation technique. And the notion of t-SNE is to keep the distribution of the neighbor points from the original data when transform the data to a new space. And the mathematics for the t-SNE is quite involved. So we just look at this example. For example, this is a type of higher dimensional data called Swiss roll. And we view from different direction. Then after we have mapped or projected data to a two-dimensional space. So you can see this is a good transformation and this is not so good transformation. And with this, it's quite clear to know the distribution of the data on a two features map. So next we will implement an example in Python for t-SNE. If you are interested in the Python code, you can download this file from this link. And we also have a website for Python and R training on weekend. This is a paid course on weekend, 2 days, about 8 hours, if you are interested in. So next we go to Python. For this file, we just first load these packages. And we can just skip most of the part and go to the end of this file just to nonlinear dimensionality reduction techniques, because the first part for principal component and linear discriminant analysis, which have been shown in the previous videos. So here we just go to nonlinear part. So first we use the load digits function from the package we have imported. So the digits loaded, then digits data is a NumPy array. So we get the first 4 examples and store in this images file. So we can show images file, images object, shape 4 rows, 64 columns. So this is the data for the image. And next we show this data in the matplotlib. So this is 4 digits, 4 examples, and we use imshow function. So, and for the total data, digits.data, shape about 1800. So next we set y digits from digits target and x digits from digits data. So we will not do machine learning here, but we just set the y digits for the class. Class is 0 to 10 or 0 to 9, right? These 10 digits just for the plot purpose. So we can use the t-SNE using this class t-SNE with components 2, because we will plot a two-dimensional data space. and initialize it with a PCA and a random state, for example, 1, 2, 3. This is quite simple. So this instance is created, and we can use this to fit transform X digits. Run. Take a little while. So it is finished. So next we can plot projection. This function is just plot all the sample data from, of course, this data is the new transformed data on a scatter plot, and with the colors and the labels for this data group. So we just run this function for the X digits t-SNE and Y digits. We show how it is going. So you can see 1, 2, 3, 4, 10 groups. So you can see the data quite clear when we transform the two-dimensional, right? So here you can see each color, and with this color, all the points grouped together, and we also set a label in the median part of each group. So this is a very simple and basic for t-SNE technique in Python. Thanks for watching.